All right, finally in our game engine, we're actually going to delete all of this from the previous tutorial, and we're just going to start with a node 3D. All right, very first thing, we know that we need a fixed camera, which is great because that means we don't have to code any camera stuff. We're going to move it out on the z-axis so that we can see whatever we put here. If we use 1 on the number pad, it will take us to an orthographic front view, which is just super flat, true side to side, right? And I think this is how we're going to set up our game. Now, we learned previously about the meshinstance 3D. It's just a super basic node, so there's really no need to do additional research there. I would just be wasting your time. So we do a box mesh, and we are going to scale it vertically and horizontally. And then we're going to move it over to one side. We're going to do Control D to duplicate it. And the goal right now is just to recreate the screenshot. Just with cubes, just so that we have that we're looking at the same thing. One thing that is sometimes helpful when dealing with camera stuff is to go down here into 2 viewports. And we can select the camera and go like that to preview what we're doing in this top screen, which would be like this, right? First problem we're really running into is that I did not account for the view of this camera being so to the side. So let's go in here and just look through the properties that a camera has that might help us. Projection, orthographic, might be useful to us. If we look here, we can see this little red dot that usually means something in the editor can be pulled. And so we're going to pull this, and it looks like it's the view of the orthographic, which is great. So now we've got our 2 paddles in view. And that's going to be sufficient for our camera for right now. I'm just not that worried about it. We're going to duplicate this with Control D again. And finally, this will just be our ball. Okay, let's run the game to see if that's working. Okay, we can only see the ball. Looks like this yellow window is maybe where the camera can see, where the screen will be. So we'll just pull that out until they all fit. And now we've got what we want. So next step after mocking up a screenshot is to start giving parts of the screenshot functionality. And we're going to turn them into what are called scenes. Much like our main scene is a node with some children, other scenes are the exact same thing. So we're going to take the ball here. We're going to rename it ball. And we are going to right click it and go down to Save Branches Scene. And we're going to call it ball. Now, if we click this Open in Editor button, it's going to take us to the scene. Anything we change here will be reflected everywhere that a copy of this scene appears. So if we were changing an enemy, all of the enemies would change. There are features to change the behavior of this. You can make things unique so that they don't automatically update, but it does not matter for this project. So we'll delete that example. Now we know that this is going to need physics. It's going to need to collide with those paddles. So at this point, we should go back to the docs and figure out what we can about physics bodies. So we're going to go F1. We're just going to go physics. We're going to scroll down until we see kind of like a top level object that we can figure out inheritance from there as kind of a landmark. So physics body 3D is an abstract base class for 3D game objects affected by physics. That means that it's not meant to be used. It shares functionality between other things that are meant to be used. If we look at inherited by, we've kind of got character body 3D, physical bone 3D, rigid body 3D, static body 3D. I happen to already know what these are. And so rigid body uses the physics system to resolve kind of like bouncing and hardness and mass and that sort of thing. It could be really funny for this project, but I don't actually think it's the way. Character body 3D allows you to use the physics system for things like collisions, but then you code the movement yourself. You figure out what angle it should bounce at. And I think it's going to give us better control over what we want for a kind of arcadey game that doesn't have like gravity and mass and that sort of thing. As you can see, there are a bunch of good tutorials here on how to use these things. And I do recommend going through them when you're not busy working. We're busy working. We're going to use the knowledge that we have to do the work that we need to. This is an opportunity to talk about kind of scene organization and management. So we know as a top level object, a thing that goes into the game and doesn't depend on some specific parent or anything like that. It's just a game object that we want to be able to tell this ball to bounce. And that makes character body 3D the most appropriate space for this object. So what we're going to do here is we're actually going to add a character body 3D. We're going to right click it and we're going to go down to make scene root. What it's going to do is it's just going to change the parentage. So that the mesh instance that we had doesn't get deleted. It's still here. We're still a cube. But the character body 3D is the top level node. Now, why that's important is that when we say, oh, hey, I want to interact with this ball, make it bounce, we don't have to go through any levels of indirection. We can just go directly onto what this thing is, which is it bounces. We can also change this later if we don't want to be a mesh instance 3D. We can be other types of nodes without breaking the whole thing. What this object relies on is physics. And that is why we're going to make that the top level node. If we take a look, we see we've got a little warning here. This node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 3D or collision polygon 3D as a child to define its shape. So let's do that. Add child node, collision shape 3D. You get another warning. A shape must be provided for collision shape 3D to function. Please create a shape resource for it. If we slide over here to shape, we'll see that it's empty. We just get ourselves a sphere shape 3D because it's a ball. I understand that the graphics right now is a cube, and that is super not important at all. People will get caught up bringing in finalized assets for prototyping, and it drives me crazy because it's a waste of your time. You will many times throughout development change your mind about vibes, atmosphere, mechanics, things that you thought were going to be important artistically, like visually, just aren't. They don't fit, they don't run well, or whatever. And when you do the assets first, you lock yourself into those decisions. So try to prototype with cubes, just plain cubes, as much as you possibly can, graphically. But gameplay-wise, we know we want it to be a ball. So I'm going to use a sphere because that makes sense for the gameplay, for the mechanics. Now, somebody out there might be tempted to scale this with R and be like, oh man, I want to scale my shape. And it's even going to complain at you. Don't do that. Use this little red thing and just change the radius. If you scale a physics object, you're going to get problems. I don't know all the specifics of why, but try not to scale physics objects. So we save that and we go back to our main. And now we're going to have a ball that has, we can see that we've got a little warning here. With a non-uniform scale, this node will probably not function as expected. Please make its scale uniform, the same on all axes, and change the size in children collision shapes instead. That's everything I just said. I guess they added a warning. To view the transform of an object, which is the collection of its scale, rotation, and position, we go over here under node 3D. So we're just going to go down here to scale. And what you can see is everything that you've changed has this little reset button next to it. It's very convenient. I hope every program in the world adopts this and starts doing it. Because instead of trying to go in here and put 111, you just click that, reset it to be a normal cube. So you'll see that our cube is still narrow, and that is because we changed our base type to character body 3D. The mesh instance is now a child of that. It's no longer the main thing that we're interacting with. It has its own local scale under its parent. We could reset that to be a full-size cube. We could set it real small, and it's independent of the physics. Okay, so now that we have our physics set up, we have our visual set up, that's really all that this ball needs other than code. We're going to correct our naming here a little bit. Call this the mesh. Collision shape is fine. We're going to call this the ball. And we're going to call that the ball so that in our main scene, it appears as ball. So we're going to go in here and we are going to add a script, just ball.gd. Now we have a choice to make here. The template, we can include this kind of example script of basic movement for character body 3D, or we could go with an empty script. But I looked through it briefly before, and it didn't have anything actually useful. It was more confusing than helpful. So we're just going to uncheck it and go with an empty script, and that will be good for us. This is the time that we start thinking about those entry points that we mentioned before. Process, physics process, input, unhandled input, and signals. The big one that I missed before was ready, and that is the one that we need to think about right now. So when our object begins play, when it comes into the map, should it do something one time at the beginning? And in the case of the ball, yes, it needs to start traveling one way or the other. So we'll set up our func void, and we need to have something in here, so we'll put pass for now. And then we'll include a comment. And this is a good way to map out your code before you make it. So comment is just any line that starts with a pound sign. And so we can come in here and say, move either direction at start. So then we think about, what does this need to do every frame? And we need it to move according to the physics system. So it's going to be in physics process. So we go func underscore, and we start to type physics. But that's a lot of friggin' letters. So we just tap tab, and it auto-fills the rest when you hit tab. And we'll go in here, and we'll just put a pass there as well. And we'll map this out as, in physics process, we will move in current direction according to speed. Now, I just had a great scope creep idea. What if the ball sped up every time you hit it? That is the sort of thing that we'll write down, because that sounds kind of rad, and our game's already pretty small. But we should not immediately add this. This is definitely scope creep. So ball increases. The reason we write this down, even though we know it's scope creep, is to get it out of our heads. We want to get back to the task at hand. And I'm going to be thinking about this in the back if I don't write it down. If I write it down, it's gone, and I can get back to it later when I'm not working. So we know that we need it to move either direction at start, and we know that every physics process, we want it to move in the current direction according to speed. So what we actually want to do up here is set either direction. And this is where our ambiguity comes to a fine point. Either direction, is that random? Is it one direction every time? What is the actual answer to this question? Which way does the ball go at the start of the game? I'm going to say not random, because it's a one-player game. We're not making this two-player. And so it should always go towards the player to start out, and the player will always be on the right side. So we actually don't need to do anything in ready. We can just set that as the default state of direction. So we're going to keep the function here in case we think of something later, but it's not actually important right now. So in physics, we need to move in current direction according to speed. We're just using plain language to describe what we want to happen. So we know if we hit a paddle, we want to bounce back the other way, but at what angle? Do we want to go 15 degrees? Do we want it to be a function of the angle that it hits at? I really don't know. I'm going to play with this a bit. I don't know math well enough to say what the correct answer is, so we're going to play with that quite a bit instead of making a decision. It's important to know what you don't know. And I don't know the answer to this question. We're going to leave it as question marks, and we're going to play with it till we get the right number later. I have also just now remembered that in Pong, it bounces off the ceiling and the floor as well. So we're going to actually need to make a walls for this game. Is there anything else that the ball needs to do? Does it need to change color? Does it need to notify anyone of anything concerning its state? Maybe send a signal out? I don't think that it does. I think literally the only thing it needs to do is move in the current direction according to speed, and then have its direction changed when it hits something. So if we want to move in the current direction according to speed, we're going to do Control and left click, go to Character Body 3D, and find us a function that will move the ball. Scrolling down, we can see that we have a velocity, which is promising. We can see that we have move and slide. Move and slide moves the body based on velocity. If the body collides with another, it will slide along the other body rather than stop immediately. If the other body is a character body 3D or rigid body 3D, it will also be affected in the motion of the other body. You can use this to make moving and rotating platforms, or to make nodes push other nodes. That part's not relevant to us here. We don't have any rigid bodies. This method should be used in node physics process or in a method called by node physics process, as it uses the physics step delta value automatically in calculations. Okay, so that sounds like what we want. We want a velocity. So velocity is already a property of character body 3D. We can just access it like that. And we don't know what type it is. So control and left click, we go to velocity. We see that it is a vector 3. That's just a combination of 3 numbers that have some functions to help out. Let's go back to ball. Now these 3 numbers are going to be the X, Y, and Z. It is important to know which is which because it's different from 3D program to 3D program. X is your red, Z is your blue, and Y is your green. If we go back to main, hit 1, we can see that we're going to be moving along the X-axis and the Y-axis. We're not going to use Z, which would be depth. So Z should always be 0. So X, Y, Z. We're just going to put a little test velocity in here. X is going to be 10. We'll put that in ready. We'll go down here and put in move and slide like we read about. Now, in theory, move and slide should just take the velocity and move according to it. So we're going to go back to our main scene and we're going to run it. All right, got this kind of a weird technical problem there where it's converting my ball back into a mesh instance 3D. So we're just going to delete this. And then we're going to add a ball. And then that should work. Okay, so we see the ball moving and we're happy with that. Now, if we go to the debugger, we're going to see that the parameter delta is never used in physics process. If this is intended, prefix it with an underscore, which we're going to do because we're not using it manually. It's just accessed by move and slide automatically. Okay, that technical problem kind of threw off my mojo, but getting back to it, we've got velocity in the ready function. Velocity is inherited from the character body 3D, and we just use this vector 3 constructor to give it 3 numbers, and that constructs a temporary vector 3 that is then assigned to the velocity variable. So in physics process, all we're doing is move and slide. We're not doing anything else. Now, kind of the next order of business is to figure out how to determine if we hit a wall or a paddle or whatever. So we're going to do control and left click back into character body 3D. If we come down to move and slide, we can see that it returns true if the body collided, otherwise it returns false. So that sounds like what we want. And so if you recall back in part 1, one of the things we talked about was function return types and how this move and slide call is equivalent to the value that it returns. Now it does do something, which is move your thing according to the physics system, but it also returns a true or false. So we can treat this as a true or false, and we can do if move and slide, and that will return true if we did hit something. If we did hit something, we want to bounce. Now, we could put the code here. If we were idiots, if we were newbies, if we were beginners, we would type all the code here for how to calculate the bounce and all that. But since we're pros, we're just going to do bounce. And then down here, we're going to make function bounce. With this code, in theory, if we move and slide and we hit something, then we should do the function bounce, which does what? It prints we did it. So let's go back to our main scene and give it something to hit. Make sure that the velocity is something that will actually intersect with where we're going. Boom, we did it, we did it, we did it, we did it. So, proof of concept is there. Now we just have to do the math to make it bounce. Okay, so we're just going to make it do velocity times equals -1. And we're going to play it, and then in theory it should just bounce off, right? But it doesn't, and it's frustrating. So we want to make sure that this code is running. And kind of the lazy way to do that is to put a print statement. As long as this function gets called, bounce, then this print will go, which we already know, but just so we know that this function is running, but we also know that velocity is not doing what we want it to. So we want to print velocity to see what is the value of velocity when this function runs. We see that it's 0. Now it's 0 because it's hitting a static body and it's not moving anywhere after that. Its velocity is completely ground to a halt by the collision. So what we're going to do is make a variable last velocity, and we're going to make it equal to a vector 3.0, which is just a shorthand for 0, 0, 0. And every physics process, what we're going to do is we're going to do last velocity equals velocity. And it's going to give us a 1-frame history of velocity, so that when we do hit, we just come down here and we do last velocity times negative 1. And it's going to bounce. Variables at the top of the class can be accessed inside any function. It can be accessed by other objects. It's kind of a global variable that is available everywhere all the time and doesn't go out of scope. So this allows us to just use it at bounce. The cleaner, better way to do this would be not as a variable up here. We would actually make this a variable, and we would pass it as an argument to the function. And as you can see, it's functionally identical. It does not make a difference. This is just about organizing your code. So we're at least going the opposite direction now, but that's not actually what we want. We want to go at angles, right? Okay, so let's clean this up just a little bit. Let's make this 10 so it's a little faster. Let's get rid of comments that we've already worked through. You will be told as a beginner to add comments all over your code, but it is far better to just have readable code. If your code is easy to navigate and read, you don't need the comments. Comments will rot over time. Many comments are what is called code rot, which is where it was true when you wrote it down, but then you change the functionality and it's not true anymore, which makes it an actively hurtful thing to have in the code base. You want to keep your comments to a minimum. Put it in commits. Put it other places where the timeline is right there associated with it rather than in the code, because it will rot over time and you will cause problems. Okay, so we've got a reminder that we need to finish this, and we'll save this. Okay, so back in the main scene, we need to start getting some walls together so these things can bounce. I'm going to very lazily. These are not going to be visible for now. It's just there to catch the ball. That's it. And we want to turn this into a paddle. Good enough. Okay, so now we've got the ball bouncing back and forth. We've got collision shapes all over the place. Let's see if we can give it some diagonal and see what happens. So that's fine, but we really want kind of a better angle, a cooler angle for that. All right, you guys remember when I said I was really bad at math? I spend the next 2 hours going down a blind alley that is completely worthless, simply to arrive at the fact that vector 3 has a function for bounce. So ignore all of the math and all of the stupid things going forward. Just keep the concepts for the programming. All right, so we suspect that because there is a physics system, there's probably a way to get information about the collision that we had. So we're going to do Control and left-click Character Body 3D. I'm going to look through here kind of briefly, see if there's anything that looks relevant. And there's a lot of stuff here for figuring out how we should slide when we interact with something and kind of get floor angle. It helps us figure out what to slide on. I think get slide collision returns a kinematic collision 3D. That sounds like something we would be interested in. So we're going to click that. Returns a kinematic collision 3D, which contains information about a collision that occurred during the last call to move and slide. So that is what we want. Since the body can collide several times in a single call to move and slide, you must specify the index of the collision in the range 0 to -1. See also get last slide collision. Returns a kinematic collision 3D if a collision occurred. The returned value contains information about the latest collision that occurred during the last call to move and slide. Returns null if no collision occurred. So that is probably what we want, the get last slide collision. Let's go to our ball. We're going to be changing how the code functions. But because we were proactive and used a function in place of long-winded code, we can just come down here to bounce and change it. And we don't have to change anything in physics process. We don't have to change the logic. We might by the time we're done, but currently we can do all our editing down here. Okay, so I think the very first thing we want to do is get that kinematic collision 3D from the function. So we're going to do what? Variable collision equals get last slide collision. Okay, and then we're just going to print col to see what that actually looks like. What data are we getting? Not helpful. So then we'll do control and left click to go to get last slide collection. And we'll click kinematic collision 3D to see what that looks like. So it doesn't have any properties. That's important to know. But it has methods. It has functions that we can run on that returned value. Get angle seems like the real important one. Returns the collision angle according to up direction, which is vector3.up by default. This value is always positive. So this returns a float, which is a decimal number. Like I said before, when you do a function, it is like replacing the entire thing with just the return value. So this is going to give us a kinematic collision 3D. And from that, we can also run get angle, and that will just give us a float. So then if we wanted to print, that should give us the angle at which we hit the wall. All right, so this is a day later. I got 2 of my teeth extracted, and I kind of finished going down this bad math path. So now we're going to get back into it. The code's going to be a little different, but I will walk you through it. So the big change is down here in bounce. You'll see that we are now getting the last slide collision. We're calling that col. And if col is not null, then we're setting our velocity to the bounce of LV. Now LV is the last velocity, which is equal to the velocity, which is a vector 3. But that's like 7 layers of indirection to figure out what type LV is. Now, we can't control and left click bounce because the system doesn't infer that type until runtime. If we want to be able to just browse this conveniently, we need to come in here and do colon vector 3. And what that's going to do is enforce that LV has to be a vector 3. If we come up here and we try to pass 13, we're going to get an error. Cannot convert int as vector 3. But that's desirable for 2 reasons. One is that you want to know if you're passing the wrong types to your functions. It's kind of a big deal and a hard problem to track down. So you want to do this, which is called static typing, as much as you can. Secondly, it lets me control and click bounce to see what the hell it does. Vector 3 bounce returns the vector bounced off from a plane defined by the given normal n. It took me hours to find this, and now that I finally did, it does exactly what we want it to. So when we want to bounce off, what do we want to bounce off? And we do this get normal. Now get normal returns the colliding body's shape's normal at the point of collision given a collision index. All this means is that when you hit the plane, the side facing out, it's going to give you that direction as a vector 3. We can see it returns a vector 3 here. So by getting the last collision, we get the last thing we collided with, and then we get its normal, and we use that to bounce. If we don't collide with anything, we keep going the direction that we're going. Now you'll recall that we added some collision shapes that weren't visible to bounce off, and if we go up to debug, we can go to visible collision shapes. And if we run the game like that, we'll be able to see those shapes even though they don't have meshes. That's just convenient for debugging. And I'm pretty happy with this bounce function already. I do want to include some way to tweak it though. And that's going to be the next step for our script, is building levers that make this easier to set. Because right now we've done proof of concept. We figured out how to do the thing. The next step is to make doing the thing easier. And that will be part 5.